Regression function. In the last few lectures, we were going through classification. We learned about different approaches towards classification. Let us look into regression for a few lectures now. So in regression, we need to find the regression function. And how do you find it? The first thing, when you are doing regression, your aim is to minimize expected loss. So first you need to have a loss function. Then you want to find expectation of loss, right? Then you want to try to minimize this value. Expectation of loss, if it becomes 0, that is the best case, but 0 doesn't happen. You want to try to minimize this value. When you minimize expected loss, you need to see what is the value of regression function y of x. That is, in regression, you will have an input which is x, then a target which is t. So from the value of x, you need to identify t. In your training data, different values of x and t will be given. You need to find a function y of x which will map x to t. That is, now if a new value of x is provided, you should be able to find out t using this function y of x. This y of x is your regression function. So let us see what our regression function will turn out to be when we minimize this expected loss. Okay. So in case of classification, how did we define expected loss? What was the expected loss when we, in that lecture in which we discussed about minimization of expected loss, we did find expected loss and tried to minimize it. So in that lecture, we defined a loss matrix, right? There was a loss matrix which said if these are the true classes and these are the assigned classes, then corresponding to each of those, if true class and assigned class, both of them matches, then loss will be 0. If true class and assigned class does not match, that is, actually it is of some class, but we assigned it into some other class. In that case, there will be some particular loss. We marked it as 10, 100, something like that. So you can give any values, but we were able to identify these particular values because it was classification and there were specific classes. In regression, we don't have classes as such. So first I'll just write the equation that we had in classification lecture so that you can recall it. We said if k is the true class and j is the assigned class, in that case, how do you find the expected loss? You have to sum over all values of k, all values of j, right? Integral of rj, where rj is the region which belongs to jth class. Then what is the loss? Lkj. So Lkj is the loss which corresponds to the case where k is the true class and j is the assigned class, right? Into probability of x ck dx. This is what we found in classification. During classification lecture, we said this is a loss function. So here you have to note few points. First thing is loss function. Here we were able to identify one particular loss element from the loss matrix because in classification, you can particularly say that C1, C2, C3, something like this is the expected class and one among these would be the assigned class. But in case of regression, you won't have classes like this. So instead of this, what will you have to do in regression? In regression, you will have a target which is t and you will be identifying a y of x, right? You won't, instead of classes, what do you have to find? Between this y of x and t, you need to find a loss function. So this function should in some way define what is the value of loss. In case of classification, you were able to particularly say value of loss is 10 or 100 if first class is this and second class is that, or let's say if the actual class is C1 and assigned class is C2, in that case loss is, let's say, 100. You were able to say. You were able to say because classes were defined. But in regression, you don't have particular classes. Instead, those are values. That is some value of y of x. So you need to find some way of finding a loss function by using y of x and target t, right? That is what you will have to do in regression. So in regression, let us start by writing the loss function. So the decision stage in regression, it consists of choosing one particular estimate of y of x, that is y of x, which will be an estimate of target t, and this you have to do for each value of x, right? This is what you have to do in regression. So how would the expected loss look like in regression? That is, expected loss is equal to, so whatever we had in classification, let us just convert it into the regression case. So instead of summing over these things, what will you do here? Let us say you take double integral over, instead of loss function, instead of this LKJ, you have a loss function. This loss function is made out of what things? One is your target, which is t, and regression function, which is y of x, right? The difference between these two, from that you have to find the loss function. And then p of x ck, there is no ck here, right? Here it is t, target, dx dt. This is the loss function in case of regression. So I'm rubbing off the loss function of classification. Hereafter we'll be discussing about regression only in this lecture. So this is a loss function. So first thing, we have to define one particular loss function. How will you define this? L of t y of x. For this you need to find some loss function. Let us say we are taking squared loss. Squared loss is commonly taken. First reason is that loss should always be positive, right? It should always be positive. So squaring a number will always give you positive value. And the second thing is, when you square a number, when the number is larger, it gets magnified. So whenever you are identifying loss, you want that whenever the loss goes higher, it should be magnified and noted. It should have a larger effect on the model so that the model would learn not to make larger losses, right? So for that reason also you are squaring, okay? So let us say our loss function L of t y of x, this is equal to squared loss. That is, what is squared loss? How do you write it? You would write it as y of x minus t the whole square. This is how you write squared loss. Now I can substitute this value y of x minus t here, right? So I am going to substitute it here. Instead of this, we'll have y of x minus t the whole square, right? So this is the loss function. Now my expected loss is double integral of y of x minus t the whole square p of xt dx dt. Now what do you have to do? You found the expected loss. In order to minimize the expected loss, what do you have to do? You have to take the derivative with respect to y of x and then equate to 0. So whenever you want to minimize any value, if you want to minimize, what do? You first take the derivative and then you equate it to 0. That's how you normally minimize anything. So if you want to minimize expected loss, you want to first take the derivative, that is del by del y of x of expected loss. This is what you have to take. So when you do this with respect to y of x, if you take derivative of this, what will happen? There is a double integral and this dx term that should go off because you are taking it with taking the derivative with respect to y of x. And this term, what will happen to this term? If you take derivative of x square, it will become 2x. So similarly, if you take derivative of this, what will it become? 2 times y of x minus t, right? So I am directly writing it here. If you take the derivative, what will happen to this? This will become integral of, let me take that 2 outside, 2 times, this will become y of x minus t, right? That square term is lost now because you took the derivative into p of probability of xt dt. This is what remains, right? So you're following this till now? So now we have the derivative term. The next thing we have to do is we have to equate this derivative to 0. So when we equate it to 0, what will happen? If we equate it to 0, I am going to open up this, that is this term, I am going to join with this. So what will happen? I am going to separate it out, that is y of x and t, I am going to separate it out. So 2 times integral of y of x into p of x t dt. So I am separating these two terms, minus 2 times integral of t into p of x t dt, right? This should be equal to 0. Now I am removing these 2's because these are now irrelevant, and anyway this will be cancelled out. And instead of writing a minus b equal to 0, a minus b equal to 0, I can simply write a equal to b, right? A minus b equal to 0 is same as a equal to b. So instead of this, I'll put equal sign here and I'll remove this off. So do any of these terms seem similar to you? I'll do one more thing. I'll take this y of x outside, then it will be more clear. Y of x into integral of p of xt dt equal to integral of t into p of xt dt. So here, what is this integral p of xt dt? So what did we learn in case of sum rule of probability? In sum rule of probability, we said p of x, marginal probability, can be written as, in case of discrete random variables, what did we write as? Summation over all t p of xt. This is what we wrote in case of discrete random variables. And in case of continuous random variables, what will this become? In case of continuous random variables, it becomes integral over p of xt dt, right? So this term is same that you are seeing here. So instead of integral p of xt dt, I can substitute it with the marginal density p of x. So here I am substituting p of x. So this will become y of x into p of x equal to integral of t into p of xt dt. What are we trying to find? We are trying to find the value of y of x. So I'll take y of x in the LHS and take the remaining term to the RHS. That is integral of t into p of xt by p of x dt. The next step is to solve this thing. We have to remove this part. So what can we do for this? Can you connect anything with relation to the product rule? Let us try to find it out. Product rule says p of xt is equal to, we learned in the product rule lecture that p of xt can be written as p of t given x into p of x, right? P of t given x into p of x. If I take this p of t given x into LHS and this p of xt into RHS, okay, I'll simply take p of x to this side. That will do, right? P of t given x will become p of xt divided by p of x. Now this term p of xt divided by p of x, this is same as what you see here. So this can be substituted with p of t given x, right? So I'm substituting this with p of t given x. P of t given x. So now my y of x has become integral of t into p of t given x dt. And what is this integral of p of t given x dt? This is in the exact form of expectation. So that is expectation of t given x, right? Expectation of t given x. So we finally found out that the regression function y of x, it should be expectation of t given x. That is, it is the conditional average of t conditioned on x. So this is a regression function.